webinar today, where we will be talking about the latest innovation in convection section efficiency. My name is Marina Silva, and together with me we have Scott Donson. Hi, Scott.
Good afternoon, good morning, wherever you are.
And Adam Stevenson. Hi, Adam.
Hello, hi. How you all doing?
So in the next half an hour, we'll be talking about the new Rover that IGS Tube Tech used to clean the convection section and deliver significant benefits to chemical, petrochemical plants and refineries in terms of fuel savings, emission reduction, or production increase. So Adam has designed Rover, and Scott knows the commercial application. And together they will be able to talk us through the main features and benefits of this new system. Let's begin. So can we first briefly talk about what is the problem that we are trying to solve?
Well, basically, and in very simple terms, what we're trying to do is to remove the fouling from the convection box tubes and the fins that are on those tubes. So to actually get the access into the area where these deposits sit on the tubes and the fins, because by removing them, we will bring back the stack temperature to where it should be, because you will absorb the heat that is now being lost. We will bring back the performance, and when we say performance, it means the heat transfer performance from the waste heat, which is the flue gases, into your process side or your steam or whatever it is that you're trying to heat, and we will reduce the throwaway gases so that your production, your output remains where it should be, rather than being taken away and reduced. All these foulings, all these problems, all indicate convection box tube fouling, and the deposits that build up. And these deposits come from strange sort of areas. It can be in your fuel, even though you think you're in the specification range for your fuel, it could still have some kind of dirt in the fuel. So that deposit will land on your tubes. Even your burners may, for instance, not be in proper balance. May have a wrong mixture, wrong air coming in from outside. Environmentally, obviously, carries a lot of debris with it as well, depending upon where you are. So again, this all adds to fouling onto these tubes. So can we have another slide? Here we go. You see another slide.
So how do we solve the problem, Scott?
So what do we do? We've designed an ROV. Adam's with us today, who has been a key feature in the latest design of ROV. We have basically evolved from the original ROV, which was a very small unit and very compact, but it lacked the ability to do everything that we now need to do. Now we know that the marketplace and how big the marketplace actually is. So the original Mark 1, shall we say, and risen up through the Mark 6, and to the latest one, which we're now showing you today, which is a Mark 7. They've all had this little transition as they've matured, and we've overcome other little challenges as we've developed the unit, so that it can now do many different things rather than just one type of convection box. What we're looking at is restoring. Sorry, Marina, I didn't realize we were having questions in there to start with. Carry on.
No, that's right. I just thought, and what does that mean, for the plant operator or the process engineer? After the convection section is clean, what sort of benefit can they expect?
Well, you can get everything from a small benefit. From a maintenance point of view, it's good housekeeping to start with. It's just like maintaining your car in reality. All the way to the massive benefits that some of our clients have actually achieved into the millions of dollars, and return on investment has been extremely quick. And when I say extremely quick, with some occasions you're talking days. So it's been a massive benefit to them. But we generally say something in the region of 2 to 6 months is a good payback. And again, one of the best things that you're doing for the environment, of course, is you're actually bringing your CO2 emissions in line with what the original equipment manufacturers said they would be. So you're not, in fact, reducing them from where they should be. You're actually bringing them back to where they should be, which is a big benefit, because we don't want to put excess CO2 into the sky that we don't need to. And good, obviously, thermal efficiency means that you utilize all that heat that you've generated in your furnace to good cause.
Excellent. And I popped a case study as a handout where we carried out a project for Borealis, so you can see the kind of benefits that you could expect. So let's talk about the latest innovation. So that's the Mark 7 rover. So TubeTech have completed over 100 projects, which culminated in this new design. So let's go through some key features and benefits, and maybe Adam can kickstart this part.
Yeah, sure. Yeah, the Mark 7, it drives with mechanism wheels. I think most people probably know what mechanism wheels are these days. If you had a Rover with 4 wheels on it and they were mechanism, you could essentially drive in sort of any direction you want. For us, it's a bit harder because we're driving on coiled tubes inside a convection section. So basically, we drive the wheels in between the tubes, up and down, cleaning the row. And then not only do we go up and down, obviously we can climb across now. This is a new benefit of this new Rover. So it climbs across, traverses across to the next row, and basically continues to do that until it's gone deep into the furnace. Here we go. This shows it. So that's traversed across. And it does a little dance to get itself into position, and then it's ready to clean the next row. So it just means we can actually climb quite deep into a furnace and clean the whole convection section, and then we climb back and back to the access hatch, and then we extract the rover. But if you think of a crab, you just saw it there. It's like a crab shuffling over. We drive the mechanisms all in one direction, and then we lift the levers in sequence, and that gets us over to the next row. So it's a big change from previous rovers that have had to be moved manually into the furnace. So yeah, I think the video shows it perfectly.
Thank you. And Scott, what does that mean from the no-man entry or the safety perspective? You know, that the rover can move between or across the tubes.
Yeah, it makes our life a little bit easier in the operations area, because the unit is now able to, as Adam kindly put it, crab across from one tube to the next. We don't have to try and manually handle the unit across those tubes. We used to do this with, and I hate to call it the pizza tray. So we would drive the ROV onto a tray and then move the tray over. This takes this away from where we were, because it would always mean you had to drive all the way back to the hole to be able to drive it onto the pizza tray, to move it over to the tubes to drive it back off again. If you've done a cleaning pass and you've actually cleaned everything to one end, then you can actually move across a set of tubes and drive backwards on a different set of tubes. Theoretically, that's going to make things a little bit easier and a little bit quicker.
Yeah.
Thank you. I mean, let's go to the next feature. So what does self-aligned movement means, Adam?
Yes, yeah. I mean, basically, because we're driving between the tubes, then we can align very nicely and just drive up and down and climb across, and everything's in line. So we don't have to worry about guiding the rover along. In previous designs, we'd have sort of tracks, tank tracks, if you like, that are driving on top of the tubes. And in that case, you need to guide it. So we'd have a spigot at various lengths with rollers that would guide it along. But, you know, you need to make all those different versions and all those different size rollers and spigots. We don't need to do that anymore, because we just rely on the actual tubes themselves. When we've got like a 2-wheel system, a 4-inch and 6-inch, and that pretty much covers everything that we're going to work in, almost every convection section that we possibly work in. There may be some unusual ones and we'll have to make adaptations, but yeah, the self-alignment really just down to the way it drives between those tubes.
Excellent. And the next feature does not require stop.
Yeah, this relates to.
Required?
I think this really relates to the fact that you basically just put the rover into the convection section, and you've either got 4-inch wheels or 6-inch wheels. You place it in between the tubes, and what it does is it aligns itself. So there's an IMU sensor that aligns it on the tubes, and that's really basically all it needs to do. So your main choice is what size wheel for that particular furnace, but once it aligns itself, it's ready to go. And it will climb over because it uses an algorithm and software that we've developed in-house to actually climb across. So that's why there's no real setup in terms of, you don't need to know the pitch of the tubes or the diameter of them. In theory, you don't need that anymore, because you might need it. You might have that information there anyway as part of the record, but in terms of what the rover needs to know, it doesn't actually need to know that. It just needs to sit between the tubes and then level itself, and you're ready to go. I think that's what that relates to.
Excellent. And it also automatically records and takes images?
It does, yeah. It takes photographs and videos. So you take some obviously before the clean and then some after, and maybe investigate if there's any issues in there or refractory that you want to make a note of that's in the way. It needs to be removed. But yeah, it'll record everything, and it also outputs a report of actually where it's been and what it's cleaned as well.
And Scott, how could you use that for the inspection or the overall maintenance strategy of the furnace?
Our project managers can take that information and form it as part of their report at the end of the job. So it means that the client can be given some very good and detailed images, and any parts where we think there are concerns can be highlighted in the project manager's report.
Automated cleaning and move functionality. So what
Yes.
does this refer to?
The one-button command. It's not exactly a one-button command, but it's a one-button start command. This relates to the fact that the rover's got LiDAR point lasers on the front and the rear. So once you put it in a section, you could, in theory, it can measure the distance to the back wall, measure the distance to the front wall, and then it can allow for its own length, and also allow for a lance length if you're lancing, or a flush length if you're flushing, and it will take all that into consideration, and it will then drive back to a set distance that you've set, which is usually about 450 mil. It's from the back wall, and from there you can press start, and it will just go up, down, clean, crossover, up, down, clean, and just go through the whole section, and then climb back after it's finished to the extraction point. So yeah, I mean, you can't always do this because you might not have a section small enough. I mean, the LiDAR range is about 12 meters, but you've got 2, so you can double that in certain sections. But yeah, in theory, you can clean. The guys they'll put the rover under pressure, so they'll put the 1000 bar on if it's lancing. When it climbs over, usually we come off pressure to climb over, but you possibly could keep the pressure on for the flush bar, but the lancing would come off pressure. So for the operator, that's all they need to do in that scenario, is just basically watch the rover and come off pressure when it climbs each time. So yeah, that's the one-button command.
Excellent. And flush and lance available on the same system, and I think we have a video clip of that as well.
Yeah, it just means you can deploy one rover and it can flush the top bank first of all, and then you can remove the flush bar and fit the lance head, which just clips onto the front, and we plug into the main unit, and then you can lance as well. So you don't need to deploy one rover to a certain, you could in theory deploy one rover to a job, and it can do all the flushing and all the lancing, and then with a quick release head. So it's just quicker and easier than having to set 2 rovers up. You can just use the same one for both jobs.
Pretty much leave the rover inside the convection coil, and just reach your arm in and change over the head, rather than having to bring it out and do a mechanical change.
True. Yeah, very true. Yeah, I think this is just
so power off and restart functionality.
Yeah.
How does that help?
I think that just speaks for itself. You need to know where you are. If you stop somewhere halfway through the clean, and the power goes, it has a memory feature to know what it's cleaned and where it is, so that you can start again once the power's gone back on. So it might be that you removed it and it could drive back to where it last was. It will know where it was. So it's just a power issue. You know, if you're having power issues, you must know. You need to know where you've cleaned till, so you can carry on from that point. So we've got that feature on this rover.
And the LiDAR control distance sensing?
Yeah, this is just positional information. So as I mentioned before, we've got LiDAR point lasers at the back and the front. So as long as there's a wall there, they'll give you distance information. And if there isn't, then we rely on the wheel kind of speed per second feedback from the wheels coupled with the LiDAR. So we can use either, or we can use combined to have the most accurate positional information. So that's what that relates to, really, the LiDARs.
Mm-hmm.
This is worst case scenario,
like an
I think.
important part. So the super over. Okay.
Sometimes when you come across a heater, you'll find bits you've not been told about, and they become challenges on the job. And this does happen. And what we have here is basically an override. So that if we do come to a heater where the ROV is pre-programmed, it knows the length of the tubes, it knows how to measure everything, it knows how many tubes wide, etc. It can do all that by itself. But you come to a heater where something has changed dramatically, and all of a sudden you need to override what the unit's actually doing, and take over yourself. So we have an override to let the operators deal with the unit at that point.
Yeah, I think it's probably a bit better, this system, in terms of if the pitch is wrong or the diameter of the tubes is incorrect. Luckily, this system can probably adapt to that quite easily. But certainly other things, there's always things that change. And just to be rest assured that we can change the settings on site when we're there, we need to. Oh yeah, agree with what Scott said.
Excellent. And the support plate climbing function?
Yeah, support plates are just part of the construction, really, of the bundle of coiled tubes. They need to be there mainly to hold it together. But at times they can come above the tubes. So if the rover comes along, it's just like a brick wall, it can't get through. But in our case, up to about 50 mil high, we can climb over it with this new rover. And I guess it climbs. We've done the crab. Similarly, now we can do the caterpillar kind of. It will come along and it will lift its pairs of legs and shuffle itself over until it's completely over the support plate. So Sorry, mate, go on.
Yeah, and another good point from my point of view and from the operators as well is that the latest one, this system of being able to lift the legs up, go over, and drop a leg down again, as Adam called it, the caterpillar. Is the fact that it doesn't need to raise the head of the unit to climb over the intermediate support plate. So the actual body of the unit stays pretty level at 50 mil, at the 50 mil climb, whereas the older systems would all need to climb up, go over, drop down, and come back down the other sides, which meant you had to have a serious amount of headroom above the ROV.
Yeah.
Excellent. Well, now we've actually gone through all the features of the rover. We'll be there's quite a lot of questions in the chat, and we'll get to them in the next 2 minutes. Just a quick overview of IGS. We discussed one of the solutions that we offer to energy and chemical plants. There's also a range of other solutions that IGS offers. Among them, HVTS for corrosion and erosion protection, which can be applied within process vessels, towers, columns, heat exchangers, and boilers. So we covered TubeTech, which is one of the services IGS offers for fired heaters and furnaces that help reduce emissions, increase production, reduce fuel consumption. Another service that complements the TubeTech offering is the CTech. So TubeTech works in the convection section, CTech works in the radiant section. Together, the benefit can be quite significant. In addition to that, there's a hot tech service it's emergency maintenance service that can be applied to live heaters during the normal operation. For example, if you have a hotspot or if you have any other bottleneck or maintenance issues, these can be resolved with zero impact to the day-to-day operation. And finally, another niche offering, very specialist, very safe CUI protection that gets applied on the outside of equipment. IGS has multiple partners and clients all around the world. And just a reminder of the purpose and mission is to offer customized efficiency and reliability solutions for a more abundant and sustainable world. So thank you for attention. And now let's go to questions. There's quite a few. So we'll start from the top and work our way to the bottom. Our first question is from Gudala. Is it hydrojetting or any chemical solution to dislodge the hard and sticky scales?
Okay, the system is based upon hydrojetting, so we can operate up to 1,000 bar. In general, we run around somewhere around 700 bar, which is about 10,000 psi. This is on the jetting lancers, and we use a low flow of water. Therefore, you don't. Oh, what happened there? I lost everything. Sorry. So you don't create vast amounts of water, and we work in a very precise area. So it's about 100 mil, about so big circle. That's where the pressure is. Outside of that, it's a washing action. So yeah, water is what we use. Water will remove pretty much anything that's inside the unit. So anything you've fouled it with, we can pretty much take it away with water. Nothing much more special than that. Where you have stainless steel tubes, we have been asked to use a 5% soda ash solution. Again, not a problem. It's something that we've done before, and I'm sure we'll get asked to do again.
Scott, and no problem with very hard, very sticky fouling. No. You've removed it all, right?
Yep.
Excellent. So next question from Steph: what moves across the tube sheet in a convection section?
Haven't we covered that off already? With the intermediate.
Is it just across the tubes?
No, I think what we're being asked here is how we get past up and over the intermediate tube supports. Obviously, there's a certain height we can go to, which is a roughly 50 mil above the fin. A lot of the majors now that manufacture these units and do the designs more than anything. We're educating them slowly that they have to change the type of intermediate tube support plate, basically, to make life faster for the cleaning and make the maintenance side easier for the plant. And they're taking that on board, which is great.
Yeah, it's obviously better if it's below the surface. Yeah.
So next question from Gudala: how does the Rover reach the intermittent tube rows between top and bottom tube rows? So that would be a lance, right?
How does it reach the? Sorry, I didn't hear that.
So you have each tube rows, you have the top and the bottom. How does it reach the rows?
How does it reach in between? Yeah, that's with the lance. So yeah, the roll of the lance has got an angle that matches that of the actual bundle, so it can get through to each layer. What we used to do is clean each row down, each layer down, if you like. But actually, what we've gone to now is more of an oscillation. A lance, it oscillates between 2 points, because usually when we flush the top, we clean quite a lot of the first 2 rows. So usually we start about the 3rd row down and oscillate 90 degrees as we drive. Just a time issue, so we can get it clean quicker. And yeah, so it's a lance basically that gets there. And we can adapt for different, if there's severe fouling, we might just set it at levels and drive up and down several times. But yeah, that's how we reach it. That's the patented part of our system, really, and was of the old system, the lance, how the lance gets into the bundle.
Thank you, Adam. And I guess the rover doesn't need to fit into a space between the two rows because the lance does, and the rover just drives on the top row.
It's the lance, the arm that goes down between the tubes. We don't fit between the tubes with the ROV. The ROV fits between the banks. So it sits on top of a bank, and then the arm, if you can imagine my pencil here, would then just drop down between the tubes, and we go backwards and forwards. So this cleaning head here actually does all the work exactly where we want it.
Yeah.
I feel like we need an animal reference here. We had the crab, we had the caterpillar.
And now we have the pencil.
Would that be okay, the pencil? Maybe a verse anteater? I don't know. Right. Is a question from Claire, is this Mark 7 standard now for future projects? Good question.
It's going to be. Okay. It's at the moment, it's out on another job as a prototype. And this will be a very testing project for the Mark 7. We are hoping that in the coming months, and I'm not quite sure what the lead times are involved here, but we should have a herd, shall we say, of these things. And
well, we should have two of them ready by end of April. We should have two production. From
the man there, you've just heard it. End of April, we'll have two operating built units for out into the service. But that obviously depends upon how many projects we're running at the same time. We still have Mark 6s and Mark 5s that we're filtering through the system. And as they, as the Mark 7 comes on board, they'll slowly become obsolete as the Mark 7 takes over. So soon it will be, yes.
Thank you. Next question from Stefan. So the spacing between the banks can now be smaller with the latest rover.
Yeah, I mean, we can do a minimum height, but we do need to be able to lance, which means we need a certain amount of space to rotate the lance down, and we've got a hose in there obviously as well. We've got a DN4 hose on this lance, which is the smallest hose we use, but we do need headroom for that lance. In terms of flushing, you can probably get quite low now, probably certainly lower than our previous rover to flush, because you've got a flush bar and you don't need much height, and the hose actually runs parallel to the rover. So for that one, you probably can go down in size. The lance, maybe you could go down. I mean, we could actually use smaller wheels in certain applications. I mean, it just depends on what the application is. In general,
let's probably not set the challenge too much, shall we? Let's not.
Yeah, we prefer a reasonable size so that we can just fit in comfortably and clean. But yeah, this is always an issue that we come up against, to try and get a smaller and smaller and flatter rover. So yeah, we're looking at it constantly.
Next question from Aravindan. What about the debris and the liquid being injected? Will it harm the refractory?
No. Simple answer. The debris actually falls down. We use gravity to help us there, and the washings from the water. So the debris is picked up and then it just drops straight down the heater. We move down the heater because we start at the top, we work our way down. So that we're forcing the debris that sits on the tube below down till it falls out, and it's then picked up in a catchment below the convection box. It doesn't harm the refractory. Water doesn't harm refractory. We don't blast the refractory, so the cleaning head is kept well away from the refractory, so it won't cause any damage that way. So mechanical damage, and the water really just touches the surface of the refractory. And again, because of gravity, the water rolls down the side of the refractory, gets a little bit wet, a bit damp, but dries out very, very quickly because we're not soaking the refractory.
And do you protect the refractory with anything? Or it's not required?
Well, with there's no need to protect the refractory in the convection section, because that's all castable refractory or castable brick. The refractory that needs to be protected is actually in the radiant section, And we ask that a containment area is built below the convection section before you get to the radiant area, so that all the effluent, all the water, all the moisture is collected, and it doesn't go into that position at all.
Yeah.
Thank you. Next question from Godala. What is the flow rate and the pressure and the temperature of the water jet?
Water gets hot because you put it under pressure. As I mentioned earlier, the pressure of the unit is actually it has a working pressure of about 1,000 bar, 15,000 psi. Invariably, we don't work that high because we don't need to, and we'll very often run somewhere around 700 bar, which is 10,000 psi. Water flow rate wise, I think the jetting arm works at something around the region of about 24 liters a minute, and the flush bar can work up to 67 liters a minute, I believe. But that depends on the setup and how much space we have in the unit.
Yeah, we've got 500 bar, haven't we, for the flush bar? So that's at 500 bar.
So that brings the pressure down, but the volume goes up. So it's not anything we've had any problem with. If you're concerned about your tubes and your fins, bear in mind this is not a fin fan radiator. These are steel tubes with steel fins, and not aluminium fins. So you can pretty much jump up and down in these things.
Next question from Andreas. How do you control your water use so that it doesn't flood the refractory, especially on the floor?
The problem
with the bund, isn't it? It's captured.
Yeah, we
talked about that, didn't you?
Yeah, we've talked about the captivation below the convection box. Yeah. This is where we collect all of the water, the effluent, and all the dirt. And believe me, you will be surprised how much dirt comes out of your heater convection area. It amazes people that they don't think it's that dirty, and in reality, it's clogged up and it's not nice. But yeah, we're not looking to put it on the floor of your heater. We're looking to contain it and then bring it down from that contained area into an area where you can dispose of it correctly.
Yeah, it usually goes into a large plastic tank underneath, and then we remove it as we need it. We certainly won't drain away into your drainage system, or it needs to be captured and removed. So that's how it works.
Next question. If someone has a convection section with 5 rows of studded tubes, how would the third be cleaned?
Using the arm. The cleaning lance reaches down between these tubes, so that the arm can then get into that position on the third row of tubes, drive backwards and forwards while we do the cleaning, and then drop it down to the next row on the fourth row, and do the same cleaning there.
Yeah, in theory, if you had a lance long enough, you could go right through the whole bundle, but we're restricted to kind of 1.2 meters is pretty much our max for our lance. But you can go down literally that much from the head of the Rover into the bundle, so which usually covers most rows. And with the lance, we can have a forward-facing fan jet as well, which cleans through the bundle as well as a rotary, of course.
Next question from Andreas. We have more than 5 rows in one of our plants. The space in between tube is very limited. Maybe you can comment on, what is the maximum amount of rows and the minimum amount.
Yeah, don't think about it as a maximum amount of rows. We have to think of things as distances. You may have 8-inch tubes with 25 mil fins on. You may have 2-inch tubes which are bare. So the 5 rows is a big difference on the size of tube and the size of fin. Best thing we can do there is actually look at your drawings and do a project review, and a technical review for it, and have a look at the best way to clean the coil. Small. How big is a small space? One man's small space is another man's vast space. So we need to look at them from a dimensional point of view. Send us your drawings, basically.
Thank you, Scott. I believe you already. Yes, send the general arrangement drawings. Scott will review them.
As built drawings.
As built. Awesome. I believe we covered the part about how the
yeah, we're not putting water onto the burner floor, okay? The burner floor is protected away from that because the burner floor is where the radiant section is, and the water isn't going into there.
Comment from Kutala, a video clip on the actual cleaning of the tubes. We have a 3D video and we have the live video on a demo rig. I believe it would be very unsafe to place a camera inside a convection bank.
I think,
when the Rover is,
Kutala, if you're that interested, I think what we should do for you is a presentation. If you can let Marina have your details, then we can get whoever is the business development manager in the area to show you a video, or we can set up a Teams meeting for another date. And I have many videos of the various different ROVs that we've had over the year doing various different things. And yes, I have these videos.
So question from Goral, how many heaters in refinery cleaned so far?
Well, so Marina surprised me with this one yesterday.
Projects.
So Marina, let him know.
107 projects so far, probably more, but we've only started counting recently after changing the CRM system. So good question. What are the difficulties generally faced during the cleaning? What have you come across?
You've skipped one, actually. Impassivation of tubes is required before hydrojetting with Rover. You can use the 5% soda ash solution to passivate your tubes if you're concerned. Generally, it's for stainless steel tubes, but if you want to use that, then that's fine. But you have to supply that. We don't carry the solution. It's something that site would have to give us. Sorry, carry on. Oh, good. What is the time duration?
What's the time duration?
How long's a piece of string? Okay, we get asked this a lot, and the old answer used to be one bank, 1 day. Unfortunately, that's not really a great answer because I look at heaters, and the first bank on a heater can take three shifts. And then after that, you might find the next coils and the banks are like a 1 shift per day. So there's lots of things that I have to take into consideration when looking at that. And again, I can go to, for instance, a fertilizer plant, and the heater is huge, so that can take 15 days or 15 shifts to clean a big heater. But we're looking at we're just guys overseas at the moment. We have a 2-day job, and we have a 10-day job. So it all depends on how big the heater is, and then it's down to, let's have a look at the drawings. Let's work with the drawings from there.
Also how quickly you can get the permits. That's always a big problem. But yeah.
Great. Question from Hamlin. What might be the disadvantages in the application versus traditional methods, and what are your learnings?
Well, when we look at traditional methods, I mean, we're so far in advance for the level of cleaning that we can actually provide. I think that the only downside we have is we can't clean these things online. It has to be an offline job. But that's really the major disadvantage.
And online,
I don't know what traditional methods are. I'm going to say it must be to put a hydrant in it to clean it, but yeah, I don't know.
No, going traditional methods are usually covered by either chemical cleaning or dry ice. So.
Oh God, no. Yeah.
Will IGS provide the catchment tray or the refinery has to? We asked the refinery to actually provide this. It's a scaffold build. Basically, you have scaffold contractors on site. These guys are professional at what they do, and they will build and construct a suitable receptacle, shall we say, and then just line it with plastic so that it contains the liquids, the effluents there. We can help. We very often arrive on site. So, what have you thought about, perhaps doing it this way? Because we've seen your design of heater before, and it lends itself to a specific way of trying to contain and drain the effluent. But we're not scaffolders. There are people out there that are professional in that job.
Mm-hmm. And can waterproof tarpaulin be used for water containment?
Exactly what is used, yes.
Okay. And I believe I've seen those pictures. The Rover is also useful on the studded and fin tubes.
Certainly is.
Tubes.
Yeah.
Great. And have you done any projects in India?
We are working on a few at the moment. I'm hopeful that at least 2 of these are going to come to fruition. Yes, hopeful. We were very close actually before COVID. We were at the planning stage, and unfortunately COVID struck, and then everything just got pushed back. So, but those projects are now coming back live again. So, I'm hopeful in the next 6 months we will be pushing hard to get back into India.
And as IGS, we have done a number of projects in India. Most recently, a CTEC project where we improved the efficiency of the radiant section in a CCR. Right. Next question, Liam. So you said the lance is 1.5 meter long, right? So if your banks are longer than that, how would the lower tubes get cleaned?
Yeah, I think our maximum lance is probably about 1.2, but in certain occasions, maybe 1.5 would be literally the maximum. On certain jobs, we've tried to clean from underneath as well with the Mark 6 Rover. So we've literally pointed the lance upwards, but it all depends on whether we can build something that we can drive on under there or what the situation is. But generally, we're flushing, so you've got a lot of water falling through anyway, which is cleaning the lower banks, the weight of the water. And also saying we've got the double lance, which one of them's a rotary lance and one of them's a forward lance. So that's actually pushing through the bundle as well. So you are getting more of a clean, it doesn't just stop at the level you're at with the lance. You are cleaning below as well. But if it was an incredibly deep bank, then we could possibly clean from underneath as well. It depends on access, really.
Great, thank you. And I believe that was our last question. So we're ready to wrap up. As Scott mentioned, if you'd like a follow-up conversation about your specific heater, as built general arrangement drawings would be what Scott would need. And you're also welcome to request either in-person or a Teams meeting with your plant for a deeper discussion. If you just direct your attention to the polls, this is where you are able to indicate your interest, and have a look at the handouts as well, where you can see the presentation that we delivered today, the white paper that this presentation is based on, as well as a case study where the TubeTech Rover has been deployed. To contact us, I'll put a general email in the chat. And all the emails you send to this will be redirected to your local representative. Right. Well, thank you, Adam and Scott, for your insight. It was great to learn more about the new Mark 7 TubeTech Rover. And I hope everybody else and you have a lovely rest of your day.
Yeah, thanks for listening, everybody. Thank you.
Thank you. Bye-bye.
Cheers. Thanks. Bye.
Thank you. Bye.